Hi, today we're going to be looking at solving inequalities. We're going to solve some simple inequalities with addition and subtraction. You can find this in the textbook in lesson 2.9, which is going to be our homework tonight on page 106. Let's get started. When we're solving an inequality, it's very similar to solving an equation. Here's an example. If I have the equation x plus 3 and it's equal to 5. Now, when I solve an equation like this, I would typically subtract 3 on both sides and get the answer 2, so x is equal to 2. Now, in an inequality, as you see here, we have that x plus 3 is greater than 5. So something added to 3, lots of numbers added to 3 would be greater than 5. I would solve it the same way. I would still subtract 3 on both sides, and what I would get is that x could be any number that's greater than 2. Okay. What you'll see me do then is, I don't know why suddenly my thing is pausing, I'm sorry. See, we would be subtracting 3 on both sides, which basically is doing the inverse of adding 3, so I'm subtracting it, so x is equal to 2. Or I would also do the same thing for an inequality, except for instead of an equal sign, you'll see me use the greater than sign. So x is actually greater than 2. So for example, a number greater than 2 would be 3 or 5. So if I were to put 3 plus 3, I would get 6, and that's greater than 5. Or if it was 5 plus 3, 5 plus 3 is 8, and 8 is greater than 5. So any number bigger than 2 would work, even 2.1. 2.1 plus 3 is 5.1. So 5.1 is greater than 5. Let me show you a couple more examples. So it's very, very similar to solving an equation where we draw a line. Our line would just be through the greater than or less than symbol. So here in this question, I'm going to take the inverse of subtracting 5 and add 5. When I add 5 with negative 7, I'm going to get negative 2, and x is going to be less than negative 2, and I just keep the symbol the same. So it's important that you don't accidentally put the x behind the negative 2 or move the inequality symbol to the opposite side on the right side of the negative 2. You want to keep everything coming down in your inequality straight down. Let's look at graphing, I'm sorry. So we're also going to graph. So again, x is less than negative 2. It doesn't include the negative 2, so I'm going to do an open circle, and then I'm going to shade to the left. Please refer to the last video. The last video goes through graphing, so if you're still having a little bit of trouble with graphing, or why we use an open circle or a closed circle, or when to use it, you might want to watch the other video. And because we did review in class already, we may not go over extensively, so please make sure to do that. Here's number 2. X is added with 4, and it's going to be greater than or equal to 5. So instead of adding by 4, we're going to subtract 4, okay, which is simply 5 minus 4, which is 1. And I'm going to keep the greater than or equal to sign, and that x is greater than or equal to 1. Now I can choose and check my answer by choosing any number that is greater than or equal to 1, maybe like 10. And so if I take 10 and put it into the inequality, 10 plus 4, is that greater than or equal to 5? Well, 10 plus 4 is definitely greater than 5 because it's 14. So now I'm going to graph. Here's my graph. I have a x is greater than 1, so I'm going to use the old man and do a solid dot at the 1. And it's greater than, so I'm going to shade to the right. Let's look at 3. You'll notice that this time the x is on the right side of the inequality symbol, so I do want to keep it on the right side as I'm working out the problem. X is subtracting with 2, so let's do the inverse of subtracting with 2, which is adding 2. Now, negative 6 plus 2, that's like losing 6 and then gaining 2. So if I've lost 6 but gained 2, I should still be in the negative, so I've got negative 4. You'll notice I still write the inequality symbol, less than or equal to, and then I have my x. That is the same thing as writing x greater than or equal to negative 4. So what I did is I just flip-flopped both of the variable and the numbers, and I flip-flopped the inequality symbol to write it properly, because this is the proper way of writing an inequality. Because when I read it, I'm reading left to right, and from left to right, x is greater than or equal to negative 4. And then I'm going to graph it. So here's my line. My number line, I want to be at negative 4, so I'm going to go all the way to the left side and do a solid dot. And since numbers x represents numbers greater than negative 4, then I'm going to shade to the right. And here's number 4. I have y plus 8 is y plus 8 is less than 5, so y plus 8. So instead of adding 8, I'm going to subtract 8. So if I have 5, which is a positive, so I've gained 5, and then I lose 8, minus 8. So if I had 5, but I lost 8, then I'm going to have negative 3. And then I'm going to keep my greater than sign and my y. Then I'm going to write it properly, so I'm going to put the y on the left side. So I'm going to do y less than negative 3, and I just flipped everything around, the y, the negative 3, and the symbol from greater than to less than. And y is less than negative 3. I'm going to go to graph it on my number line. I want a open circle and a negative 3, and because it's less than, I want to shade to the, very good. Oops. Alright, try these 4 problems by yourself. So pause, and when I come back, we'll continue. So number 1, we have 16 is less than x minus 4. So here my x is on the right side, which later I do want to move to the right side. So if you want to, you could set up the problem already with everything flipped. Okay, so then you could write x minus 4 on the left side, write the 16 on the right side, and then make sure you flip the symbol as well. Okay, it's like looking at a mirror. But I'm not going to flip it until the end. So instead of x minus 4, instead of subtracting 4, I'm going to add 4. I'm going to add 4. 16 plus 4 is 20. I still have my less than symbol and my x on the right side. Then I'm just going to flip-flop everything, so x is greater than 20. And since x is greater than 20, when I go to graph it, I've got 20 right there. X is greater than, I'm going to pick an open circle, and I'm going to shade to the right. Here's number 2. Y plus 7 is less than or equal to negative 1. Instead of y plus 7, I want to do the inverse of adding 7, which is subtracting 7. So then I have negative 11 minus 7, which is the same thing as losing 11 and losing 7. If I've lost 7 from the 11 that I already lost, then I'm going to lose quite a bit. So I am going to add. So you'll start to notice that if it's the same sign, negative negative or positive positive, when you're adding and subtracting, you want to add them together because you've got lots of them. So we get negative 18. My y still stays on the left side. My symbol is still the same. This is the proper way of writing my inequality, and so I'm going to leave it just as it is with the y on the left side because I'm going to read it. Y is less than or equal to negative 18. There's my number line. I'm going to do a solid dot, and then y is less than negative 18, so I'm going to shade to the left. And here the last two, I'm not going to explain them. I'm just going to show you the answer. And if there's any more questions that you have, definitely feel free to ask me during class, in our homework assignment that we're doing. This is not your homework assignment. This is just some practice to help you with your homework. So good luck. Have a great day. This is how we solve inequalities with addition and subtraction. Bye.